Welcome back, my concrete design friends. In this video, we're going to talk about torsional requirements for reinforcing in members subjected to torsion. So without further ado, let's get started. All right, so welcome back. In this lesson, we're going to talk a little bit about the details of reinforcement for torsion. There's a lot of extra little requirements that are required, and so the intent of this video is to walk us through the locations of where these requirements are, and I've kind of summarized them to kind of help speed up the process for you. Okay, and so I'll kind of walk us through a little bit. I know it's a lot of code provisions, and I'll kind of show you that the book does do a pretty good job of illustrating and highlighting some sketches that will start to kind of make some sense. But the majority of what we're looking at with regards to torsion is found in two chapters. It's found in section 25.7, and then it's also found in 9.7 with a couple of other odds and ends found in 9.6. So we're going to be looking at chapter 9 and chapter 25 for this. Okay, if you remember, the strength requirements for torsion were all located in 22. So we're kind of work on those pieces of it. All right, so the first requirement, when we flip over to the page, I actually closed my book, okay, is going to be located, and I'm not intending to read from the code directly, but I am going to kind of summarize it. The majority of the details related to torsion are found in these two provisions here, 25.7.1.6 and 25.7.1.6.1. Okay, and it's kind of, there's a lot of words here, but what it basically sums down to is kind of a picture of over on the next page. Okay, and what they're wanting to make sure, the first requirement for torsion is that stirrups have to be closed. Okay, for torsional strength or for the torsional requirements, you cannot have a U-shaped stirrup. It has to be closed all around. And part of that is because when we did the truss model, we were designing for the torsional steel in one face. But we also said that when this section cracks due to torsion, it forms that helical pattern. So a crack in this face propagates into the top, then propagates into this, and then propagates back around to the bottom. And it kind of winds its way down the length of the beam. Okay, and so I want to make sure that you have a path for that. I see him. I got him. Okay. All right. Okay, and so that's kind of what we're looking at. So there's some requirements on, it has to be a closed stirrup. It can be a stirrup made up of two parts, okay, but they have to be anchored with like 135-degree bends, and I'll show you those provisions and the requirements. But it has to be a closed stirrup, otherwise you cannot count on any steel for torsion, because it will crack the next section, and there won't be any torsional steel for it there. So this is kind of the picture that kind of tells all of it. There's also some mention of what will happen is that based on these ties that we'll discount the corners will spall off, and that's one of the reasons for these hooks as well, and why we only count the cores. That we start spalling the corners, we start spalling the faces off. Okay, so the requirements as they're called out here, I'll just kind of walk you through on this. For stirrups, if you remember, we talked a little bit about how these had to be anchored. Okay, for shear, this is what it looked like. For torsion, there's an added requirement that any hook that you have has to have a longitudinal bar that goes in it. So this is the shear picture. These pictures are different. Okay, and this is also for welded wire fabric, which we're not concerned with in this. All right, so here are the requirements, kind of as a summary of what's in those two pages on there. Okay, first one is that we require closed transverse reinforcement, meaning no single or no U-shape. So I can't have this anymore. That's a no-no. We're not allowed to have that. No. Okay, what you can have is you can have a U like this, which is a standard U-shaped stirrup, but then I can also take and put a second bar that's developed according to proper guidelines that does something like that kind of wraps around. Again, we're putting a bar here, if you will. And so this forms a closed stirrup, even though technically it is two pieces. You're allowed to do that. Okay, now, there is a requirement for the transverse reinforcement that you have to have a 135-degree bend. So when we did this guy, and this was our bend, and we're bending it around there, that angle has to be 135 degrees, okay, unless you're confined by some sort of slab on the top. What they're worried about doing and what they don't want you doing on this is to come in and say, all right, I've got my U-stirrup fine, and I'm just going to put a bar that comes around straight and then comes around here, something like that to help make the close. Because what happens is as torsion moves through this system, if I don't have a proper anchor around a longitudinal bar to hold it down, and I don't have a slab or a flange on top of this beam, imagine the torsional force coming down this bar. What's it going to do? It's going to try to pop this guy up. All right, and so this top bar is going to try to pop out like this. And with only, a minimal amount of cover, like, an inch or an inch and a half of cover, you could potentially pull this bar through that distance. So what they say, and the other requirement that's in this is that if I have a slab or a flange, around the longitudinal bars, then that's less likely to occur. That I don't necessarily need the standard hook. In general, as a good practice, it's best to try to hook bars around this whenever you're doing torsional calculations, just not to have to worry about it. In my opinion, it's a stronger, better detail for that. Okay. All right. The next one is that transverse torsional reinforcement must extend a distance of BT, which this is the width at the torsion location. Okay. If you remember, we've seen BW, which was the width of the beam in flexure. This is the width at the location of the torsion. So if it's a hollow-shaped wall, BT is the thickness of the wall on that, okay? And so we must extend that by an amount of BT plus D, okay? D being the depth of the beam or the depth of the longitudinal reinforcement. So, if this was my longitudinal reinforcement, this would be D on this. Okay, and what they're doing is they're basically, so even though, if I go find another piece of paper, real quick. Say that you've gone in and you've designed the torque here, and I've got, a bar that's here and a bar that's here as a longitudinal. Here's my section. Here's my section, and we're applying a TU amount here, and we're doing a TU amount here as my torque being applied to this, okay? If this is the section that I've designed for, what they're saying is, this will be my critical section for torsion. You might generate a torsion diagram and start sizing and setting the spacings based off of this. If this is the last location needed, or the location that I'm considering as the value that helps me choose the areas, I have to extend this way an amount of BT plus D extra, okay, for stirrups. So now I've got, so say I put one here. This is the one that I'm doing for my critical section. Okay, I have to continue on with the same spacing for a minimum of that amount of distance. Okay, and the reason for that, again, is because of this helical crack. If I develop a crack here, on this one at that critical location, this bar captures this one, but as this crack propagates down and then we go across the bottom, now it's this bar over here that's arresting that same crack. Does that kind of make sense? Okay, so we've got to kind of extend it a little bit further than what would normally be thought of, and that goes for both directions relative to the end of what's what they call an end of what is a needed by analysis. Okay, does that kind of make sense? So we've got to kind of extend it. It's almost like, remember how when we were doing developmental lengths on these bars and we extended LD past that critical point where I needed FY. It's the same thought process. Now you're adding additional bars at certain spacings for an additional length as we start to kind of look at that. And that's the requirement that they're talking about here in 9.7.6.2. Okay, now, there are some other details that aren't torsion specific that I'm going to point out that make this a little bit of a challenge, getting those longitudinal bars anchored, because remember, we need to consider longitudinal bars as well as transverse in our torsion analysis. All right, so if I flip over to 9.7 on this, okay, then, where'd it go, 9.7? We're now looking in a section up here in which we're talking about reinforcing detailing. Okay, and in particular, we're looking for 9.7 flexural reinforcement for non-pre-stressed beams. Okay, this is the extension that we're talking about, but it's what we want to see. What was the section on that? 9.7.6.3.2. I need to flip back a little bit. Didn't quite go. Okay, here we go. If you go to 9.7.5, you can see this is the longitudinal torsional reinforcement requirement. Okay, and we'll talk a little bit. We'll come back around to that one. But if I flip even further, it's the transverse reinforcement that we're starting to kind of look at. So here are the requirements that I just showed. Here's the requirement: longitudinal torsional reinforcement shall extend for a distance of at least BT plus D beyond the point required by analysis. Okay, and longitudinal torsional reinforcement shall be developed at the face of the support at both ends of the beam. Okay, so your critical section for torque is the face of the support. Now this is a challenge. All right, think about this. If you have a small column on this, and just like the problems we had when we were doing longitudinal reinforcement in flexure and developing that, now we're looking at a picture that if this is my beam, and this is my column right here, even though the torque is applied way out here on this guy, okay, your critical section for torque is right there at the face of the column. Okay, it's not plus D like we do with shear, it's at the face, which means that if I'm trying to anchor, let's just say we're trying to anchor a negative bar up in the top, I have to provide either LD or LDH, depending on if you put a hook or not, to get those bars anchored in, starting at the face. It's no longer at the critical section or out in the middle somewhere, it's here. And so if you're trying to anchor like a number 8 or a number 9 bar and this is 30 inches, that becomes a real challenge trying to get this thing tied into a column. Okay, so that's one requirement that we got to kind of keep our eyes on, is getting the critical section and getting that development on both sides, really. Okay, for developing the longitudinal bars, because I need FY for torsion in the longitudinal bars here. Okay, so that's another issue. The other one that shows up is what we call the structural integrity requirements. And you'll find those in 9.7.7.1. So, and this is the one that's kind of the gotcha in a lot of detailing. We haven't talked about this one a lot. What structural integrity is kind of, instead of being reinforcement that provides strength for a single member, it's now reinforcement that connects one member to another. Okay? And so if we look at this, when we're talking about, so for beams along the perimeter of the structure, this is around the outside of a building on there. Structural integrity reinforcement shall be in accordance with A through C. Okay, and the requirements are that at least 1/4 of the maximum positive moment reinforcement, but not less than 2 bars, shall be continuous. What that means is that if I look at this in plan view, now here is my column here, and if I have a beam that's coming in like this, and it consists of, say, 4 longitudinal bars needed for torsion in a particular face of this thing, that requirement says at least 1/4 of those have to be continuous through the support. Okay, well in this case I'm just going to draw 3 bars. All right, that at least one of these bars, then, if I want to terminate this here, say I don't, that I don't need all of the torsional steel, one of these guys, whether I need it or not, 1/4 of 3 is, 1/4 of 3 is 0.75. We're going to say 1 bar is that requirement. All right, and if we do that, that means that 1 bar of this has to be continuous through the cross section into okay, into the next beam on this. Okay, there's also some seismic provisions that will kind of change it. So that's the first one. Okay, so that's for positive reinforcement. Okay. All right. Does that kind of make sense? Okay. The next one is that at least 1/6 of the negative reinforcement must be continuous through. Okay. But not less than 2 bars. So if you've got 3 bars, you have to extend at least 2 of them through on there. Okay. And again, this is kind of helping to connect one piece to the next. Okay. The other one is that longitudinal structural integrity reinforcement shall be enclosed by closed stirrups, okay, in accordance with the sections that we're talking about, or hoops along the clear span of the beam. So I can't just, even if I don't need, if we're looking at our picture, man, that glare is horrible. I'm so sorry. There we go. Can I get that? There we go, a little bit. It's bleaching out really bad today. Okay. So say I come in and I need, I only need to provide, a transverse reinforcement here. You have to continue to supply them all the way over the length of that section in what they call the clear span. This is the clear span, the beam that's happening here. Okay, so I got to keep adding reinforcement and adding that for structural integrity. And part of that is, again, to help protect the developmental length of the guys that I'm continuing through. Okay. All right, so that's what we're looking at. Okay, now again, in the column, you're going to have something that looks, like this. You'll probably have a stirrup coming around the column. If I close it, and then here is where we've got the transverses in the beams. That is what we're kind of talking about today. Does that kind of make sense? Okay, so there's a certain amount. So 1/4 of the positive moment, 1/6 of the negative, but not less than 2 bars. Okay. Okay, and it's not less than 2 bars for the positives as well. Okay, so when I said, that my calculation said 0.75, but we must use 2 bars minimum. Wow, that's horrible. Okay, there we go. I don't know why I'm being overexposed. Let me tilt that a little bit. Okay, all right. Okay, with me so far. Okay, the other requirement for structural integrity is for all the other members other than the ones that are going around. Okay, so we're now looking at the next page. Okay, and so for other than perimeter beams, structural integrity reinforcement shall be in accordance with A or B. Okay, so again, at least 1/4 of the positive moment goes through, and longitudinal reinforcement shall be enclosed by closed stirrups. So that requirement is the same for each, but what happens is around the outside of the building, okay, along the perimeter beam, we also get, again, the negative moment. This option B is a requirement around the outside of the building. You guys understand what I'm talking about when I say a perimeter beam on this? Let me draw a sketch for you. Keep that in my lap. All right, so if we have, let's just say we have a section of concrete that is being framed something kind of like this. Okay, normally RC concrete framing looks something such that the columns are connected with beams. I'm not showing the slab on this. This is here all the way around. The ones that I'm drawing on this picture right now that's a perimeter beam. Sometimes they're called as band beams, but they want to make sure that this guy is tied to this and this guy is tied to this, and that there's this continuous circuit all the way around of a certain amount of the steel to kind of help hold all those things together. Okay, so that's a perimeter beam. Okay, the ones that are here, and I'll draw those in dashed lines, the ones that are framed in the middle are not perimeter beams, and they're bound by the other requirement. Okay, so here we're looking at the M positive requirement and the M negative. Here we're only looking at the M positive. Okay, but we still have to be continuous across the column, so I still have to continue a minimum amount from this side to this side of longitudinal bars in those beams. Does that make sense? Okay, all right. That gets us that one. Okay, the next part of it, okay, so that's a little bit of detailing issues. Now we get into minimum steel areas. And remember we did these calculations back when we were looking at shear. So now we're looking at 9.6.4.2, okay, and it says where torsion reinforcement is required. Okay, and we talked about that last time, you know, that when we're over that threshold torsion, you know, or the cracking torque divided by 4, when torque is higher than that, we need torsional reinforcement. Our equation looks something like this, and you recognize these two terms, I hope, in shear. Remember when we did AV minimum, it was 50 BW over Fy. Well, that's still the minimum, okay, and then 0.75 square root of F prime C BW over Fy was the other two, and we choose the larger of these two values, okay? But what's changed now with torsion in the picture, we now modify our formula. Instead of just being AV over S, it's now 2AT plus AV over S, all right? And you've got to pay special attention to AV and AT, okay? And we talked about that last time as well. This is total legs of your shear steel. This is one leg of the torsional transverse, right? So we got to kind of watch what's going on here. So we get to count two of these because there are two of these in the outside of the picture, right? Again, if we do a multi-set, let's just say that I have multiples here, 1, 2, 3, 4, 5, 6, like this, right? That's an AT, that's an AT, but all 4 of them are AV. Remember how we kind of talked about that? Does that kind of make sense? Okay, all right. All right, so watch your subscripts down here on the AVs and ATs. Okay, that's the only change in this for the minimum torsional requirement, but that side is still the same. You choose the larger. Okay, now, as we've talked about with our truss models, torsion also has a restriction on the amount of longitudinal steel, okay? And so the amount of steel that you have to provide for torsion addition, and this is in addition to what's required by flexure or what you've done required through the truss models. This is the torsional amount that you have to add in. There is a minimum quantity here that is the smaller of these two equations, okay? And what it is it's 5 square root of F prime C ACP Fy minus AT over S, and then the perimeter of the stirrup PH, okay, and then FYT over Fy, okay? So again, they're taking the area of the torsional steel and dividing it by its spacing. It's that AT over S parameter. So a lot of the calculations we do have to look in a form of AV over S or AT over S, because the spacing obviously is affected by the area of the bar that we're using. Does that make sense? Okay. All right. And then the other minimum requirement then is instead of AT over S, they're going to bound it by 25 BW over Fy, and the formula is exactly the same. And you'll choose the smaller of these two as the limit, the minimum amount of the longitudinal that you'll have. Okay. All right. And what this is, this 25 BW is kind of an estimate on the amount of stress that it takes to hold a crack in place. Okay. There we go. Turn that light a little bit. Okay. Haven't had this kind of lighting problem in a long time. Okay. All right. Everybody good with that on that requirement? All right. So that's the first page. So those are your minimums. Minimum transverse, minimum longitudinal. Okay. All right. The next piece of the puzzle then is kind of the spacing requirements of the reinforcement. Okay, so we've got some A minimums. We're now over in 9.7.6.3.3. How's that for a number? Okay, down there. And for torsion, the transverse reinforcement spacing says the minimum spacing between sections of, stirrups that you're adding for torsion on this. Again, if this is a side view, and I need, you know, one here, and then I do one here, this is the clear distance, and that's S min. Does that make sense? Okay, so they're saying it's either 12 inches as a maximum or pH divided by 8 as the spacing between the bars, between successive stirrups, if you will. Again, our moment or torque is being applied in this direction. Either positive or negative, doesn't matter. All right, okay. There is also, in a similar section, there's a couple of requirements that come out of 9.7.6.4. The first one is in 4.2, says that if your longitudinal bar is a number 10 and smaller, the smallest stirrup you can use is a number 3. If you have larger bars than that, you have to use a number 4 as a minimum size for the stirrup. Okay, and generally that's pretty reasonable. That's kind of what we saw with shear. It was the exact same thing. All right. Okay, another check on our S minimum. Okay, is that the minimum spacing of the transverse reinforcement is 16 bar diameters of the longitudinal, 48 bar diameters of the transverse, or the least dimension of the beam. Okay, so that's in addition to what we were seeing up in 6.3.3 that was, you know, that was being used up on this requirement. So you've got a couple of different ones happening here. Okay, and again, it's all about trying to keep those cracks arrested based on the size of the bar. So that's why the moral of the story with torsion is you have a longitudinal requirement and a transverse always that you're looking at based on what you choose. Okay, and of these you choose the smallest. Okay, all right. The last requirement, and where we'll kind of end our discussion, has to do with the distribution of the reinforcement around a cross section, and in particular with regard to bars in compression. So this is kind of the same game with kind of compression reinforcement in columns, but it also works for torsion. Okay, that again, you have to have a closed stirrup. It has to be 135 degree hooks at the end around a bar, or to be 2 bars that meet the developmental requirements as we talked about. Okay, every corner and alternate compression bar shall be enclosed by a corner of transverse reinforcement. Let me show you that requirement so you see the wording on that. All right, we're looking down here in 9.7.6.4.4. Okay, the longitudinal compression reinforcement shall be arranged such that every corner and alternate compression bar shall be enclosed by the corner of the transverse reinforcement with an included angle of not more than 135 degrees. Okay, so if you think about what that's saying, is that's saying that for any stirrup that we set up, okay, that a minimum of 3 bars are contained before you have a corner on a bar. So if I have, say, a section where I've laid out the steel for torsion such that it has 4 bars, like this, I would have to have a corner here, and the requirement says I would have to have a reentrant corner there to meet that criteria, right? Okay, and at the outer corners of this, clearly I've got to have a corner here, which means now I need one here. See how we've kind of chosen how those are being laid out? So that's kind of, so there's, once you know the number of bars as you've set that requirement, and another factor that sets the number of bars is that I have to have a minimum of 6 inches clearance. Okay, at most. Okay, that these bars have to be, you know, less than or equal to 6 inches clear between them on the torsional requirement. And that's the last half of that paragraph. Okay. And so of not more than 135 degrees, that's the hook requirement, and no bar shall be farther than 6 inches clear on each side along the transverse reinforcement from such an enclosed bar. Okay? Which means that your torsional spacing is going to be about 12 inches maximum between corners on these bars. Does that work? So again, here's the 6 inch limit that we were seeing. Okay, but now if I go to 2 of those, here's 12 inches. And again, that's kind of an approximate value because again, this is the clear spacing requirement, which means if you remember clear spacing, if this is a bar and this is a bar, this is a clear space. Okay, not a center to center. Okay, does that kind of make sense? And so this one produces some challenges because, obviously if you want your longitudinal bar, this is what, for torsion, what this is going to do is it's going to say, instead of using two numbered 10s around the cross section of this thing for a beam that's fairly big, it's going to make you spread that steel out so that I'm going to be, instead using, 5 number 6s. It puts a lot of stirrups or a lot of bars around the perimeter of this thing and gets you into a lot smaller sizes, which the idea being there is that now by limiting it to 6 inches, I have more bars that will keep the cracks from growing wider and wider, these torsional cracks. And if I can prevent it from growing in this face, I will protect all of the other faces around it as that crack starts to form a helical crack around the section. Does that seem logical? Okay, so this limit is pretty steep. This is one that I hadn't seen. It used to be a 12-inch dimension for years and years and years, but as I was going through this version of the code, so I'm not sure when it changed, this is what I saw, and that's the provision that I saw. So they've tightened it up quite a bit. If it's a torsionally designed element, you got to have your longitudinal steel distributed completely around the entire cross-section, depending on the dimensions of the beam. Does that make sense? So that's a pretty stringent requirement. So if you know you need if you know because of the spacing I have to have at least 5 bars, well then when you do your AT calculation or your AL calculation for the face, what you'll do is you'll divide that number by 5 instead of by 2 like we would have done in flexure or in columns, if that makes any sense. Right? So there's a lot of thoughts that are going in on the details of this. So we got to be kind of careful and very mindful of that. So I hope that's kind of made sense to you, if you got any questions, leave some feedback down in the comments below, and otherwise make sure you like and subscribe to the video, and we'll see you guys next time.